binary input output. So earlier this semester, about 3 or 4 lectures ago, we talked about text files. And we saw that we can actually read and write to text files. We can create a file object, which basically it's an abstract way to view an object. And then we can create a scanner to read from the file, like we read basically from the command prompt, input command prompt. And we can create a print writer to print to the output file, like we print with system.out into the output file system, to the output file, stream. So text files are human readable. If you open them, you will basically be able to read from these files. But as you know, probably most of the files are binary format. So if you open, for instance, with a text editor, a Word file, a Microsoft Word file, you will see that it is in fact a binary file. It contains unreadable characters, meta characters, and so on. So why all of these applications? And these include not only text files, but also binary files, but mostly all of the files that you have on your file system are binary files instead of text files. And the advantage is that binary files are more efficient to process, and also they occupy less space. So for instance, the number 123 in binary is just 1 byte, as opposed to a text 123, which is actually stored on 6 bytes, at least in Java, because it uses UTF-16, and for every character, it has to use 2 bytes to write and read that character. But people don't read binary files. Binary files are really designed to be read and written by programs. And today we'll talk about binary files and how to read and write them. As an example, the Java bytecode classes, basically the class file that is obtained with the extension .class for every Java file that you compile, is stored as a binary file, and they are read and written by the JVM, the Java Virtual Machine. So let's compare the two approaches. So text files have the advantage that they can be read by humans. They can be written with Notepad or other Emacs, VI, other editors that you can actually write files. And in fact, source files like source code, Java source code, is text files. They are readable by humans, writable by humans with text editors. A text file consists of a sequence of characters. For instance, if I want to encode the decimal number 199 in a Java source code, it will be stored as a sequence of 3 characters, 1, 9, and 9, into a single text file. Java, for instance, is UTF-16. So when it saves a file, like for instance a source code, it saves it with encoding UTF-16, which uses 2 bytes variable encoding for characters. In fact, it uses 2 bytes for characters with Unicode less than 2 bytes minus 1 bit. And it uses more, it uses that last bit, the first bit in kind of right from the left. It uses it for continuation to another byte if the Unicode is bigger than what can be stored on 2 bytes. In the case of 199, 199 would require 6 bytes to encode it, 2 bytes for every single character. As opposed to a binary file that consists of a sequence of bits, and every information, like for instance the decimal, the byte 199, is stored into a single byte binary value. And the reason for that is that 199 in hexadecimal is C7. Each hexadecimal digit can be stored on 4 bits, and therefore 2 hexadecimal digits are stored on 1 byte, and this 199 value is stored in 1 byte. In fact, any value between 0 and 255 can be stored in 1 byte. and we don't need more than 1 byte to store it. Now, for text input output, we remember that if we want to read and write to this file, we can create a file object, java.io.file, and it basically it encapsulates all the properties of a file. If it's read, write, if it's basically exists in the file system, if it's a folder or is a normal file. And in order to perform as any input-output, we will need to create objects with appropriate Java input-output classes, scanner for reading from the file and print writer. And here we have a simple example in which we actually have a print writer that we create for temp.txt. We write to this file, basically Java 101, then we flush from the temporary space, basically the main memory, to the persistent storage, to the flash drive or to the hard drive. And then we can read the same file with a scanner. And this is very easy to see. If you actually want to try it, like always, you can actually copy and paste pieces of code in Eclipse. Let's actually start it because we'll need it for our binary input-output examples. And you can basically create a text file, write to it, append to it if you like, and also read from that text file. So let's actually take our test.java file because that's what we usually use for tests. And we basically put the two pieces of code. First, we write to that file. And in fact, if you run this, it will basically write to a file which is in the project directory. So in our case, temp.txt contains Java 101. And we can read from that file. So we can create a scanner for the file that we actually just created. And because scanner throws an exception, we can actually, first of all, read. Let's actually try. And it basically read exactly what we just wrote to that file. So we wrote to the file, and then we read, and it's the same information as before. So these are text files. If you open that file, it contains every single character that we had in our test, and it will occupy basically 2 bytes per every character that we have in the text. So in this case would be 9 characters, including the new line, at least if we consider the new line is a single character, and that would be 20 bytes to encode this information. Okay. So let's actually clean up, delete the files that we created before, and continue with binary input-output. So text input-output requires an encoding and decoding that is invisible to you as basically a user of the Java JVM, but basically the JVM takes the Unicode character and writes it to that file-specific encoding. So every single text file contains an additional property. What is the encoding of that text file? So in fact, for the previous example that we had one encoding for the text file, which was invisible to us, but we can actually see it here in the editor itself. So if we open that temporary file, we can actually see what is the encoding. I don't see it available, but usually it's in properties for that file. The status bar is not visible, in fact. Okay, I will find out how to actually see the encoding, but usually the encoding is visible if you use an external system editor. And in this case is UTF-8. It saved it with UTF-8 because all of the characters are in basically ASCII code. So most editors will basically show you what's the encoding of the file, and based on that, you can actually reason about how much space that text file takes on your system. So the way that the text input output works is the JVM converts the Unicode of the character to the file specific encoding before you write a character, and then converts a file specific encoding to Unicode when you read that character back. For binary, you don't have to do any such thing, because binary means that the byte is written to the file in that original form, and when you read it, you actually still read a byte from that file exactly as it was originally written. So there is an encoding decoding scheme that takes place in the text input output, and we can also see that, for instance, for 199, it basically writes multiple bytes in the file. Now, if in this case 199 is again, it's basically a string, and it's all ASCII characters. So if writing it into a file, it's written as ASCII characters. For binary input output, if we write 1 byte to the file, that 1 byte is written to the file, and we can read it in the same way. Now, Java has an entire hierarchy of binary input-output classes. 2 of the classes, which are abstract, are the roots of input streams and output streams in Java. Input stream is an abstract class for reading binary data, and output stream is for writing binary data. And in fact, we have a lot of classes that are subclasses of these classes, and is a good example for applying inheritance and seeing that, in fact, common operations are inherited, and additional classes, subclasses can implement additional, if they want, methods to basically read and write binary objects. So the input stream class. The input stream class contains methods to read an array of bytes. So first, the read method with no arguments reads an integer. It basically reads the next byte from the data stream, and the value of that byte is returned as an integer value between 0 and 255. If no byte is available, if we are at the end of the stream reached, then the value -1 is returned by this method. Read, that takes an array of bytes, the reference to an array of bytes. It reads up to b.length bytes from into the array b from the input stream, and returns the actual number of bytes that were read until it ended up to the end of the stream. If we are already at the end of the stream, it returns -1 because it didn't read any byte. Read into an array bytes, starting from an offset until the end of until the end of length, basically the length of how many elements will read. It's very similar to read byte, with the exception that it basically reads the bytes from indices offset to offset plus length -1. And again, it returns the number of bytes read, in which case, if it read all of them, it will return len. If it didn't, it basically meant it ended up to the end of the stream, it will return the number of bytes that it could read. If it was already at the end of the stream, it will return -1 as the return value of that method. Available returns the number of bytes that can be still read from the input stream. So basically, you can actually see how many bytes are left in the input stream. Close is the input stream and releases all resources associated with the input stream. So this is a method that you saw in the case of inputs from a scanner, output to a print writer, that you need to close in order to basically flush the main memory into the disk in the case of a print writer, or just liberate space. Skip skips over and discards n bytes from the input stream. So instead of reading them, it just keeps a number of bytes in the input stream. And if we didn't reach the end of the stream, it will return the number of bytes that it skipped until the end, or it returns the number of bytes skipped. So basically, in either case, it returns the number of bytes skipped, because if we reach the end of the stream, it will return a value different than the value of n that we set to skip. Mark supported with no parameters. Test if this stream supports the mark and reset methods. These two methods are used for basically moving the file pointer, and we'll talk about that more for random access files, where you basically want to test if you can actually jump to a different position in the input stream. Mark character limit will, as an integer, marks the current position in the input stream, and you can reset to get to that current position. So reset repositions this input stream at the time that the mark method was last called in the input stream. So you can basically return back to the file pointer to where it was in the input stream before. These are artifacts in order to implement that random access in binary input-output. We'll talk more about that later, because it's a special class that allows you to both read and write at any given position in a file, in a binary file. Output streams. So output streams are used to basically write into binary files. Write integer b would write a specific byte to the output stream, and the parameter b is an integer value that basically it's a byte. So byte b is actually written to the output stream. Out of that integer, the method doesn't return anything, it returns void. Write an array b of bytes, writes all of those bytes to the output stream. Write an array b of bytes starting from an offset for a number of elements length into an output stream, basically writes b of that offset, b of the offset plus 1, up to b of the offset plus the length minus 1 to the output stream. Close is important for output streams. It's as important as we had read, output writer to the output streams. In fact, one thing that you probably didn't notice is that here I have output.close. So this output.close basically makes sure that after we close the output writer, the string that is now actually written, but is not written directly to the persistent storage, is written to the main memory, is actually written to the persistent storage. So this was the case, flush the output disk. This was the case that we had for text files, but we have exactly the same for output streams. In order to make sure that we close the output stream and release any system resources associated with the stream, and also flushes the data from main memory to the output to the persistent storage, we need to close the stream. There is another method to do that, which just flushes the main stream and forces any buffered output bytes to be written out, which is called flush. The difference between close and flush is that flush does not close the current output stream, so we can continue writing to it. So it's a quite useful method if you want to make sure that what you're writing is actually written to the file system, and in case of a crash, all of the data is stored in the file system, in the persistent storage. Okay, so now let's talk about the different classes for writing and reading for basically binary streams. So first of all, two classes, file input stream and file output stream, are the basic classes for reading bytes from and to files. One thing to notice is that all of the methods of file input stream and file output stream are inherited from their superclasses. So basically, none of these two classes do not contain any additional methods. I see that I have I had a typo, and I wanted to make sure that you understand that bytes are the only thing that you can read and write with file input stream and file output stream. So in order to construct a file input stream, you can either use file input stream that takes a file object or file input stream that takes a file name as a string. And in case that we try to read from a file that doesn't exist, a java.io.file output not found exception will occur, will be triggered. So basically, this is to open a file for input. If it doesn't find it, it will trigger an exception. File output stream can be constructed either again by giving the file object a file name and append, in which case it will write to that file, but from the position of the last byte written to the file, and it can take the file name as a string, and again boolean append, which if it's true, then the current writer will append the new data to the file instead of writing over. If the file doesn't exist, a new file will be created. If the file already exists, then the default is to delete the current content and write over, unless the append parameter, the second parameter, is true, in which case it just continues from the end of the file. And this is used only to write bytes. So for instance, here we have two examples. We create an output stream for the file temp.dat, which doesn't exist on my file system yet. And in a loop, I'm iterating from 1 to 10, and I'm writing the byte value from 1 to 10. So it will basically write from 1 up to 10 included the numbers. Now, similarly, a file input stream will create a file input stream for the same file that was written out. And then while the value that is read, the value after reading the number of elements is different than -1, it prints out that value. So basically, there are two things that happen here. First, we are reading a value and we are assigning it to value. And the number of bytes that were read has to be basically a value different than -1, which is basically as long as the numbers are increasing from 1 to 10. So basically, in this case, we create a file temp.dat. Dat is usually the extension used for binary files. And we read the same values back. Let me use the test program because it's already created and we don't do anything else with it, to actually show you the example. So we actually executed the example. We wrote to test.dat the 10 values. If you open that file, you will see that it's totally binary. So you actually cannot actually see what it is. As humans, we can't read binary. But reading the bytes will actually give us the correct byte that was written to the file. So now we basically have the binary file that contains those values that we have written, but we can see that after we read them, they are actually correct. They are the values that we were expecting. Okay. So this writes and reads bytes, just pure byte values. Let's delete all of the files left in the project directory. Refresh for the next tests. Good. Okay. So as we can see, basically we just used the read method to read the next input from basically the input, and before that we wrote them to the output, and that's exactly what happened here. Now, so with the two classes that we saw before, file input stream and file output stream, we can only read and write bytes. But binary files can also be used to read and write other values. Like basically we should have read integers, read doubles, read strings, the same ones that we have for other classes that we saw this semester. So filtered streams, which are filtered input stream, filtered output stream, data input stream, and data output stream, are classes that basically provide input streams with read methods that can be used for reading integers, doubles, strings, or any one of the primitive types and object types. We'll actually see the object types a little bit later. So using a filter class will enable you to actually read and write primitive values plus characters and strings. Filtered input stream and filtered output stream are the base classes for filtering such data. And when you need only to process primitive numeric types, you can use data input stream and data output stream. So in many cases, we would like to actually write a number of integers to the output. Data input stream reads bytes from the stream and converts them into the appropriate values, type values or strings. Data output streams converts primitive types into bytes and writes them to the stream, outputs them to the stream. So they are basically opposite methods. Data output stream writes the data to the stream, any primitive numbers into bytes into the stream, and data input stream reads them from bytes into primitive values. And here we have the class data input stream. So it implements the interface data input and extends the class the Java class filtered input stream. We can create a data input stream with an input stream as a parameter. So basically, the way that Java implements these various file input output classes is called decoration. You are taking an input stream that was already created before, and you decorate it, you wrap it into a data input stream, which basically allows you to do this conversion from any primitive type or strings into the bytes that are internally in the input stream read and written. So read Boolean will actually read the Boolean value, read byte reads a byte, read character reads a single character with the Unicode encoding. Read float reads a float, read double reads a double, read int reads an integer, read long, read short, read line, reads the line of characters, a line of characters from the input until the new line character. Read UTF reads a string in the Unicode format, and we'll talk about that in a couple of seconds. It's UTF-16 in case of Java. By default, characters are read as ASCII. So read line will read the line of characters as ASCII because most of the programs and most of the strings that you actually have in file systems are ASCII. So it would be an overload to try to read and write them with UTF-16. Therefore, it's much easier to read them and write them as ASCII if they are all ASCII characters. And this is what read line does. Data output stream does the opposite. Basically, it writes into the file all of those values as basically binary bytes. So write Boolean writes a Boolean value, write byte writes an integer, write bytes takes a string and writes the lower byte of the character in the string to the output stream. The write character writes the character composed of 2 bytes to the output stream. Write chars writes every character in the string to the output stream, 2 bytes per character. So that basically does the encoding UTF-16. Write float writes the float value into the output stream. by using 4 bytes as floats are represented in Java. Write double, writes a double value into the output stream using 8 bytes, like Java. Write integer, writes the integer value to the output stream on 4 bytes. Write long, writes the long on 8 bytes. Write short, writes the short on 2 bytes. And write UTF, writes basically the entire string that you pass as a parameter with 2 bytes of length of the on the output stream, followed by UTF representation of every character in the string S. And the thing about UTF-16 is that it's a variable length encoding. So if you remember, UTF characters go up to 65,000, which would require 4 bytes for larger characters. However, Java makes the assumption that most characters that are used conventionally are what can be fit on 2 bytes. So it uses the last bit of the 2 bytes for the encoding of continuation, if it's needing another byte to basically write the character. And even that one, you can use the first 7 bits. Afterwards is the continuation bit for the encoding of 3 bytes. So Java uses UTF-16, and every character consists of 2 bytes. Write char only writes 1 byte per character code. And the idea is that most operating systems use ASCII for most applications. Therefore, it would be a waste to represent an 8-bit ASCII character on 16-bit Unicode encoding. So write char and write chars will actually write the Unicode of the character C to the output using 2 bytes. Many operating systems, again, and internet protocols, in fact, use UTF-8 to store characters because there is this assumption that most characters are ASCII. Now, for that, for write char, it will use 1 byte for values between 0 and 7F in hexadecimal. And the reason why is that it's using the last bit for continuation. Unicode characters less than 0FF, 7FF are encoded on 2 bytes. Other Unicode characters are encoded in 3 or 4 bytes. Now, data input stream and data output stream are used as wrappers to those filtered input streams that we saw before. And they basically, again, is using decoration. They are created using an input stream or an output stream that was created before and wrapping it into the data property of a data property of data input stream. So for instance, we can create a data input stream from a file input stream for the input.dat file, for a binary file in.dat. And similarly, we can create an output stream from a file output stream for a file out.dat. So basically, you can decorate it, you can wrap it with multiple layers, with all of the classes that you would need to read and write to these files. And here we have an example. We want to write to a file the names and scores for multiple students in the class. So let's say that I want to store John has 85.5, Jim has 185.5, George has 105.25, and so on. I can use a data output stream because all of these are either Unicode characters or they are primitive types like doubles. Then we can create a data input stream for the same file that we just wrote down and read with read UTF, the opposite, the mirror method for write UTF to read strings with UTF encoding, and to use the read double to read the score for that student. So basically what this sample does, it writes to a data output to a binary file, and it reads from a binary file strings and primitive type values, which can be doubles. So let's actually test it as we are doing with all our programs. So at this point, I do not have any binary files into my project. So this sample will basically write to a binary file, temp.dat, and we can actually open it and we'll see that some of the strings, like for instance, the Unicode strings, are visible in the file, but the rest are in fact just null characters. So we cannot actually read them properly unless we basically use a program that reads the doubles exactly as we wrote them. So we use the method write UTF to write strings and write double to write the primitive type values, the double values. Okay. Now, one thing to be very, very careful about binary files is that you need to read the data in the same order that you wrote it. So one thing that maybe you are not aware is that later when we talk about serialized objects, you can declare a class to be serialized and to write it to a binary file. And this is used quite often in network interfaces and network programming, because you basically need to save an object, maybe to a file, or maybe pass it through a socket to another application or to another computer. But that computer will have to deserialize the object, basically read that binary object and create exactly the same data fields that you created when you wrote to that file. Now, if you modify the class, even by reordering the data fields, you cannot read it anymore. Basically, the binary file that you had, like a score file or the state of a game, these are all unreadable anymore because reading from the file has to be done in the same order in which we actually wrote to that file. So one thing that you can see here is that we wrote UTF, then double UTF, double UTF, double. We read them in the same order. If any of the reading was done in a different order, the output would not be the same thing that we wrote to that file. In fact, in this case, most likely it will actually crash because basically it will throw an input-output exception that we are trying to read something that is not there anymore. Now, if you keep reading data from a stream, eventually you will, when you try to read, you will throw an end of file exception. However, you can actually check every time that you read how much is left in the input file. So you can use input.available to return if you still have bytes available to be read from the stream. The moment that input.available returns 0, it indicates that you are at the end of the file and there is nothing else available to read from that file. So here we have two ways, in fact, that we are writing and reading from a file. So this is a different example. I'm writing 4 bytes to a file, 3 doubles to a file. And then while we basically run that we are still in that file and we are reading from that file. And this actually shows us another way to actually see the try method, the try block. So basically we have 2 types of try blocks. We have the try blocks where we have statements that may throw exceptions and catch them. Or we have the try blocks that have a body, they have a condition in the try itself. And in this case, this is an initialization. It basically initializes the output stream to test.dat. And then we are basically writing the 3 doubles. Now, while we can read, that basically means that we didn't trigger an exception, we try to read the doubles from the file, or we can use input.available different than 0 to read every single double from the file. And in here, we basically have methods to catch the exceptions. So if we reach the end of file, or if we caught an input-output exception, we print the catch block. We basically print the stack trace. Otherwise, we just print that all data was read. So again, we are going to test this file. I'm going always to test the main method and show you that it prints exactly what we expected. So we are still in the test method. We have no code except what we basically wrote. And we are writing that we read the same values that we wrote, 4.5, 43.25, and 3.2. And again, this file is not readable because it's binary. So all of the values are binary. Okay. Let's clean up like usual. And let's continue. So the next methods are methods that are used for speeding up the input-output. So buffered input stream and buffered output stream do not contain new methods. All of the methods are inherited from input stream and output stream, but what they do, they basically allow us to create a buffer for a specified buffer size, which is the size of the memory used in the main memory to copy directly from that file into main memory. One thing that you have to realize is that every level of memory is an order of magnitude faster than the next level of memory. So for instance, if it would take 1 nanosecond to access the cache, it would take 10 nanoseconds to access the main memory. If it takes 10 nanoseconds, let's say, to access the main memory, it would take 100 at least to access a flash memory. Now, rotating hard drives are even more expensive. Usually they take 2 orders of magnitude. They are 2 orders of magnitude slower than main memory. So reading a big block into the main memory, so it's used directly from main memory, is very important. In fact, most of the optimizations for programs are done by buffering into cache into the main memory. So these two classes here are used to read with blocks into a buffer size into the main memory and write into a buffer size into the main memory instead of writing directly to the file system. So here we basically have 2 methods for reading and writing to main memory. So usually these methods are used for basic utilities, and you can think of utilities as any file and any executable from the operating system to do file operations, like copy file. Copy file is one of the most important. If you want to copy a binary file from one location to another location in the fastest possible way. So first of all, this is a copy method that basically a copy file method that allows us to copy from a source file into a target file of binary files. First, the 2 files must exist. So we create 2 file objects, source file and target file. For the argument at index 0, we are using it with command line parameters, and the argument at index 1. And in either case, we can see that the source file must exist. If it doesn't exist, we exit. And the target file should not exist already. If it already exists, and again, we exit. There are 2 things that I want to clean up into this code. And those are that one and the fact that the file name is called copy file, but then it has to be the same way defined in the help. It doesn't really matter because we are going to test it with the test method. Next, so once we have the files, we can create an input stream, buffered input stream for the file source, and the buffer output stream by decorating a file output stream for the target file. Next, we are going to basically read into the instruction R. If R is different than -1, then we write the byte of that value R into the output stream, and we increment the number of bytes copied. And we continue this until we basically reach the end of the file. At the end of the file, we basically inform the user how many bytes were copied from one binary file to the other binary file. Let me actually show you how this works. It's very important because in one of the future labs, you actually have to implement encoding, decoding, encryption methods for binary files. And many of the code that you are going to use is very similar to this one that we wrote here. So let's create copy file. Actually, one other thing is that I want to have a binary file in order to copy it. So we just created test.dot as a binary file. Then we don't need the test class anymore. Let's create a new class copy file. And let's copy the file that we have here. So if we run it as is, it basically will complain that this is the way to use it. The source file and the target file should be passed as parameters. So for us, test.dot that we saw before will be the source file. So for copy file, let's run it as run configurations. And in the arguments, the program argument for the input file is test.dat, and output will be new underscore test.dat. And run it. And we basically copied from text.dot into the new test.dot 24 bytes. Basically, this string that you see here is representing on 24 bytes. So we just wrote our own copy utility that copies every file into a new file completely identical. Okay. Next. So data input stream and data output stream enables you to read and write primitive type values and strings. But in many cases, you want to write objects. And these are serializable objects where all the data fields are serializable into binary representations. So these two files, object input stream and object output stream, allows us to read and write objects into binary format. The object input stream extends the input stream class and implements the object input and object stream constants, which basically one of these, which is object input, has an abstract method called read object that basically allows you to read an object from a binary input stream. Object output stream extends the output stream class and implements object output, which has a write object method that writes an object and also implements object stream constants. You may wrap an object input stream and an object output stream on any input stream and output stream using the constructors that you basically pass the input stream as a parameter or the output stream as a parameter. So this is the decorated pattern, design pattern. We'll talk about more about this in CSC 260. is one of the most important design patterns that allows to basically have multiple behaviors for one object, given the multiple layers of objects around the core object that is created. It's one of the most important design patterns that we'll learn. And we'll see how to create a lot of classes using a minimum number, or a lot of behaviors using a minimum number of classes in Java. Okay, so in this example, we create an output stream for object.dat, in which we write, in this case, a string, a double, and a new Java util date. Java util date implements serializable, but we can see that is a complex object. So it's not just a string or just a single primitive value. And then we close this output stream, so we flush it to the drive. And similarly, we create an object input stream for that same file. And we read the name, and we read the score, and we read the date, and we print all of them into the output command line. So the difference here is that we can write objects and read objects, and also cast them. Once we read them, we can cast them to the correct type before we assign them to variables of those types. Now, not all objects can be read and written to the output. You must have objects that are serializable. Not all objects in Java are serializable. You have to specify using the marker interface serializable that your current class is serializable, that the objects can be written to an output binary file and read from that same binary file. Now, you can actually specify that some properties are transient. That means that they are not going to be serialized and read back. But we'll talk about that a little bit later. We'll also see that static properties are not serialized. So if you have data fields that are static, you don't actually serialize them. So let's see this example. I'm going to use the test class. So all that basically is done here is saving the date into a binary file and reading the date from that binary file. So let's read it. It basically read back the same name, score, and date. If we actually look at the output file system, let's refresh. We basically have object.dat, and this object.dat contains the name, the date, and the score, but we can actually see the score because it's all binary, and this is not in an editor for binary files. Okay. So those are the classes object output stream and object input stream. So as I said earlier, not all objects can be written to an output stream. Objects that can be written to an output stream must be serializable. That means that they must be instances of java.io serializable interface. So the class that basically this object belongs to as an actual class, the concrete class, must implement serializable. The serializable interface is a marker interface. Doesn't have any methods. You don't need to add additional code to your class, except that it implements serializable. And implementing this interface allows Java to serialize the object, save it into a binary stream, and read it from binary stream. If you don't implement that interface, you will basically trigger an exception if you try to write or read an object that doesn't implement serializable to or from an input stream. Some values may not be written to the input stream or output stream. Basically, these are called non-serializable instance data fields. And in order to state that a data field is not serializable, we have to use the transient keyword. And here we have an example. The class A doesn't implement serializable, java.io serializable. The class foo implement serializable has three data fields: the private integer data field v1, the private static double v2, and the private transient value of the type A v3. And what we can see is that when the object of the class foo is serialized, only the variable v1 is serialized. Variable v2 is not, because it's a static variable. It belongs to the class itself, not to any object. And the variable v3 is not serialized because it's marked as transient. Basically, it's not serializable. If v3 wouldn't be marked as transient, then we would get at runtime a not serializable exception, because we would try to serialize an object of a class that doesn't implement serializable. So similar to our example here, when we wrote the Java util date, we can actually write an object of one of the classes that we had before. So let's take a look. We had person, and let's say that we have a person that is serializable. And if we don't want to have it as serializable, let's say that we serialize person, but person doesn't implement serializable. We pass a string like Paul. We can write it, but it actually, the moment that it reaches that line, it crashes because person is not serializable. Now, let's actually make it serializable. So instead of date, I'm going to use person. This should actually be person. And let's define that person implements serializable. So that's it. Now if I read and write to that file, it basically writes and reads that object that is serializable. That's it, basically. You can also serialize arrays. So an array is serializable if all of its elements are serializable. For instance, the write object and the read object can be reading and writing arrays. If you have an integer array, you can basically write it to the output and read it from the output in the same order. Similarly, for string arrays, because the class string implements serializable, therefore the arrays of strings also implement serializable. And again, you can just use write and read, and basically you can read and write from array files. So again, let's actually just copy this code into our test, and we can see that we can serialize arrays and we can read arrays. In this case, we read the two arrays, but we didn't print them. So if we want, we can also write methods to print the values in those arrays. So for every integer and in new numbers, we can basically system.out the value of n followed by a space. And we can see that we are reading the same values 1, 2, 3, 4, 5 that was written to the output. And similarly, we can do something similar for the string array. Okay. So one could actually add that here. I will do it after the class today because I believe it's important to see that it actually works. Let me do it now. Good. Okay. The last topic of today's lecture are random access files. So all of the previous classes that we read are read-only and write-only streams. Basically, you have input streams and you have output streams. And all of these files were sequential files. Basically, that you write to the output stream, let's say, at the end of the file, at the current file. Similarly, you can read using the file pointer. You can mark a position and return back to that position if you reset. But other than that, you can basically read sequentially that file. You can also skip if you remember, but that's, again, one way to deal with basically the file pointer. However, random access files allow you to actually read and write at random locations. And you can also open the same file for read and write purposes. So at any position, where is the file pointer currently pointing to, you can basically either read or write that location. And you can read an integer, you can read an array of a certain number of elements, fixed number of elements, and so on. So the random access file takes a file as an input and a mode, read, write, or just write, or takes a string and the mode, has the method close for closing the stream and releasing the resources. Get file pointer returns the offset in number of bytes from the beginning of the file to where the next read or write occurs. So that's the file pointer. The length returns the number of bytes, the length of the file in bytes. Read reads the next byte of data from the file and returns it as an integer, or -1 if we are already at the end of the file. Read a number of bytes in a byte array is similar to the method read bytes that we saw for input read stream before. The important method here is seek. So seek sets the offset in the bytes specified by position from the beginning of the file to where the next read, the file pointer for the next read and write occurs. So seek is the special method, the method that allows us to just jump to a certain position in the file and read and write at that position. Set length sets the new length of the file. So you are basically setting the length of the file to be longer or even shorter of the current random access file. Skip bytes skips n bytes and discards them from the file. Write byte array basically writes the dot length bytes from the specified array into the file, starting from the position at the current file pointer. And similarly for write the byte array from a certain offset with a number of elements len. So what exactly is the file pointer? The file pointer is a marker that shows the current position in this file. So it's like a cursor. If you think about one dimension line, the file pointer tells you where you are on this line. Basically the position of the next byte in the current file. If you read and write, you are basically moving this pointer. So for instance, if you read an integer, that will increment the file pointer with 4 bytes because an integer, Java reads 4 bytes from the file pointer to read an integer. And similarly, if you write an integer, you will basically jump 4 bytes, 4 positions. So the most important methods that we basically will discuss are seek and get file pointer. Many of the methods for input streams and output streams are inherited in random access files. We have read integer, read long, write double, read line, write integer, and so on. Seek is the method that sets the file pointer with an offset given by pos, the position from the beginning of the file. Get file pointer gives us that current offset in bytes of the file pointer from the beginning of the file and tells us where the next read or write occurs. Length returns the length in number of bytes of the file. Write character writes a character of the file as a 2-byte encoding Unicode with the high byte written first. The write characters takes a string and writes each character as write card does it above. And here we have an example. So let's assume that I want to write to a random access file 200 integers. So here we basically set that in a loop from 0 to 200, we write integer I to the random file access. Then we set the seek to be at position 0, and then we start reading the inputs from that file. So read int, we read basically the first integer, which was 0. The next, we seek 1 multiplied with 4, which actually moves the cursor with to the second number. And now read int will basically read the second number, which is 1. Then if we actually jump to 9 multiplied with 4, that will be the position of the 10th number. So in this case, it will actually read 9. We can jump back if we want. We can basically jump to the beginning. We can write another output. So if we write 555, now we basically have 804 bytes in the random access controlled file, because we basically added another integer at the end. And that last number is that number that we basically wrote. And in fact, we can jump at any position. We can jump at position 10 and write a number and so on. It will basically write at any random position. We can jump further or backwards. And just to show you the entire class, if we copy this code, and let's actually use the test for writing it, we can run it, and exactly we have a compilation error. I think I have the wrong number of parentheses. Yes, I reformatted it and now it's fine. We have exactly the output that we were expecting. Okay. So that's binary input output. It's very important, because if you implement any computationally intensive application like a game, if you want to save the state of the game or to load the state of the game, you will have to read and write in binary. That's all that I will teach today about binary input output. 2 of the future labs and 1 homework is basically using binary input output, and you should learn it. So that's all for the presentation for today. We have a few questions in the chat. For an object writer class, how do you write an object in binary? So basically, the way that is written, it's using 1 or 2 bytes for the type of the class that is written to the output, and then is writing every single field using the corresponding method. Like for instance, if it's a primitive type, it's using the write method for the primitive type, like write int or write double, and is writing them in the order that they sequentially appear in the source code of that program. So even if you flip the 2 data fields in the class and you try to read a binary file that was written before, it will be a completely different value. We will need to read multiple data types from an input file system stream. The object file writer allows you to read not only objects, but also primitive values. So if you need to read ints and objects, like we had in the lecture notes, date, you can see in that same example that I wrote strings, doubles, and objects. So all of the methods defined by the by the other classes that write primitive values are also available for object output streams. Okay. The last question. The labs ask us for an address field store and request it again as an additional field for music store. despite the being the same field. How should we handle that? Let's take a look at the lab. So the lab. Write a class encapsulating a web store, which inherits from the store, the class store. A store has a name, an address, a unique identifier like the SSN number of the owner, and an owner. So, which is a string. So you can use a string for the owner. A web store has the following additional attributes: an internet address, like basically a URL, www.google.com maybe, and the programming language in which the website was written. Google was originally written in PHP, and then it was in Java, and I believe the latest versions are probably in Python. Code the constructor and the toString method for the new class. You also need to include the client class to test your code. So the first class is, the first problem is basically straightforward. Write a class encapsulating a movie store that inherits from store. A music store has the following additional attributes: the number of titles and its address. You are right, the address is duplicated. So let me actually edit that. Has the following additional attribute: the number of titles it offers. Code the constructor and the toString method, and you also need to include the client to test your class. Good. Write a class encapsulating a bike and skateboard store, which inherits again from store. A bike and a skateboard store has the following additional attributes: the number of bicycle and skateboards brands that it carries, and whether it sponsors a bike club, like just a Boolean field. Again, code the constructor and implement the class and the toString method. So basically now it's correct. So you were right, the address field was duplicated. Now it's fixed in the lab. Okay, that's all for today. Please implement the lab. Remember to join the class next time because I will give a practice exam. That's all for today. See you next class. Let's put the video on Piazza. In Meet recordings, let's see if the recording for today is not yet posted. So we'll have to wait a couple of minutes for the binary class to be posted. Meanwhile, I will publish the latest versions of the lecture notes on the website for the class lecture notes. Okay. Okay, the lecture notes are updated and the video is probably still prepared by Google. Yes. As soon as it will be available, I will post it on Piazza. So please work on the lab and see you next class.